Texan Global School. Relation and functions. In this class, we will discuss the concepts of relation, function, domain, and range. Likewise, processes to create a graph. A relation is any subset of the Cartesian plane R cross R. On the other hand, a function is a set of ordered pairs, x, y, such that no two distinct pairs have the same first element. Let's look at an example. We will determine if the following relations are functions. In the first case, the points 1, 2, 2, 3, and 3, 4 form a relation since these 3 points are a subset of the Cartesian plane. They also form a function, since no two distinct pairs have the same first element. The next example is also a relation, since those points are a subset of the Cartesian plane. However, it is not a function, since different pairs have the same first element. We can see that the first element -2 is repeated in two ordered pairs. We can conclude then that every function is a relation, but not every relation is a function. The domain D of a relation is the set composed of all the first elements of the ordered pairs. In contrast, the range R of a relation is the set composed of the second elements of the ordered pairs. Let's look at another example. We will determine if the following relations are functions. We will obtain the domain and range. As we can see, the points 1, 5, 2, 8, and 3, 9 form a relation since these 3 points are a subset of the Cartesian plane. They are also a function, since there are no different pairs with the same first element. The domain, made up of the first elements of the ordered pairs, is the set whose elements are 1, 2, and 3. The range, made up of the second elements of the ordered pairs, is the set whose elements are 5, 8, and 9. We can see in the second case, they form a relation since these 4 points are a subset of the Cartesian plane. They also form a function, since no two distinct pairs have the same first element. The domain is the set with elements 2, 3, 4, and 5. The range is the set with the element 2. Finally, the last points form a relation since these 3 points are a subset of the Cartesian plane. However, it is not a function, since there are different pairs with the same first element -1. Its domain is precisely -1, and the range is -11, 13, and 23. It is common to assign a function with the letters f, g, or h. If x is an element of the domain of a function f, then the element of its range associated with x is represented as f of x. A function can be represented using set builder notation as shown on the board, indicating the ordered pairs, x, y, their rule of correspondence and domain. Finally, to graph a relation, the values of the independent variable, normally x, must be proposed and substituted to calculate the values of the dependent variable, f of x. We will see another example. We will graph y equal with x in the domain of -2 to 2 closed on both sides. We will obtain the set builder notation of the ordered pairs. The set builder notation is shown on the board, where the rule of correspondence is f of x equal to x in the indicated domain with intervals. Now we will tabulate. For this, we first propose the values of the independent variable x in the indicated interval from -2 to 2. Now, we substitute each of the values proposed in the rule of correspondence, f of x equal with x. So, f of -2 is equal to -2. For -1, f of -1 equals -1, and so on. In this way, we can obtain the ordered pairs or points of the graph x, f of x. Now, using the points obtained, we proceed to construct the graph. We draw the abscissa axis, or x-axis, and the ordinate axis, or y-axis, indicated as f of x. We graph the first point -2, -2. Subsequently, -1, -1, and so on. Once the points have been drawn, we join them, in this case forming a line. Analyzing the graph, we can see that it is a relation, since the line is a subset of the Cartesian plane. It is a function, in this case a linear function, since no two distinct pairs have the same first element. The domain is formed by the first elements of the interval from -2 to 2 closed at both ends. The range in this case is exactly the same. Graphically, there is a quick way to determine if a relation is a function. If we draw parallel lines to the y-axis, and if they only touch a single point on the graph, this indicates that it is a function. If any of these lines touches more than one point, it is not a function. We can see that if we draw parallel lines to the y-axis of the linear function in any case, they only touch a single point, confirming that the graph is a function. In this next example, we will graph the following function whose rule of correspondence f of x is equal to x squared in the real number domain. To tabulate, we propose values of the indicated domain. We will start proposing from -2 to 2. We substitute each of the proposed values in the rule of correspondence. F of x equals x squared. So, f of -2 equals 4, f of -1 equals 1, and so on. In this way, we can obtain the ordered pairs or points of the graph x as f of x. Now, we use the points to graph. The first point is -2, 4, then -1, 1, the origin 0, 0, 1, 1, 2, 4. We draw an arrow that continues at the end, indicating that the domain include all real numbers. Analyzing the graph, we can see that it is a relation, since this parabola is a subset of the Cartesian plane. It is also a function, in this case, a quadratic function, since no two distinct pairs have the same first element. The domain goes from -infinity to +infinity, because it was indicated to include all real numbers. Range starts at 0, towards +infinity. Graphically, we can see that, if we draw parallel lines to the y-axis, they only touch a single point of the graph, confirming that it is a function. We will graph the following function whose rule of correspondence f of x equal to x cubed in the domain whose open interval is -3 to 4. Despite having an open interval at both ends, we must include those two values to graph. Otherwise, we will be omitting values greater than -3 and less than 4. We substitute the values proposed in the rule of correspondence f of x equal with x cubed. By cubing each value, we obtain the values of f of x. In this way, we obtain ordered pairs or coordinates to graph. Since it is an open interval, we place an uncolored ball at the end of the graph, indicating that -3 and 4 do not belong, but all the values within the interval belong. Analyzing the graph, we can see that it is a relation, since this cubic parabola is a subset of the Cartesian plane. It is also a function in this case, a cubic function, since no two distinct pairs have the same first element. The domain goes from -3 to 4. The range goes from -27 to 64. Graphically, we can see that, if we draw parallel lines to the y-axis, they only touch a single point on the graph, confirming that it is a function. In this last example, we will determine if the following graphs are functions and/or relations. We will obtain domain and range. All graphs are relations, since they are a subset of the Cartesian plane. Graph 1 is a function with a domain of -4 open to 2 closed, and range from -3 closed to 13 open. Graph 2 is not a function, because if we draw a parallel line to the y-axis, it touches more than one point. Its domain is from 1 closed to 10 closed, and range from -3 to 3 closed. Graph 3 is not a function. Its domain and range go from -2 to 2 closed. Graph 4 is a function with a domain from 0 to 2 pi open, and range from -1 to 1 closed. The last graph is a function with a domain of -2 closed to 3 open and a range of 3. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com